The year is 1665, and the bubonic plague has reached London. Ships coming into London were forced into isolation for a period of 40 days. That's the origin of the word quarantine, which we're all quite familiar with today. Social distancing policies were enacted all throughout the city, and in an effort to protect students, Cambridge University shut down for 2 years. One of those Cambridge students was Isaac Newton, who retreated to his family home during those 2 years of social distancing that were happening at Cambridge University. Through correspondence, similar to the internet of today, Newton was able to communicate with the teachers and faculty at Cambridge University and continue his studies. It was during this time that Newton invented calculus, discovered the first modern theories of optics, and, according to the story, had an apple fall on his head at his family home and discovered, or at least modeled, gravity and the gravitational force. The big point here is that Newton was a rock star, but that learning could also happen during a pandemic. That learning was able to be accomplished from a distance during times of great peril in society in London in 1665. And so this should give us great hope that with the advanced technology that we have today, that learning can happen even more through distance and during a pandemic that's much less worse than the bubonic plague in London. So I'm not Sir Isaac Newton, and you're not Sir Isaac Newton, and chances are most of your students are also not at the level of a Sir Isaac Newton. They're going to need help to get through this time and to learn online. And so what we're going to do today in this workshop is go through what we call the Communities of Inquiry framework. And that framework will give you information about how you can structure your online course or the components that happen to be online so that they're successful at getting students to learn, to interact with each other, to interact with you. Now, before we begin, let me tell you a little bit about myself. I'm Christopher Moore, and I'm a professor of physics at the University of Nebraska, Omaha. I'm also on the leadership team of the University of Nebraska STEM Trail Center, which stands for Teaching, Research, and Inquiry-Based Learning. I'm also co-author of the curricula Experience Chemistry and Experience Physics, published by Savvis Learning. And I'm author of the books Creating Scientists, Teaching and Assessing Science Practice for the NGSS, and Teaching Science Thinking, Using Scientific Reasoning in the Classroom. I can be found on Facebook, on Twitter, and on YouTube at Chris Moore Sci, and you can reach me at my website, creatingscientists.com. Speaking of my website, we're going to use it to make this workshop interactive. So in just a moment, what I'm going to want you to do is open up a new browser window or a new browser tab and type in the web address creatingscientists.com/scienceonline. That website will open up a series of questions that we're going to be asking you throughout the workshop today. So that way we can add this little bit of interactivity. It'll also have a video of this presentation as well as the Google Slides and some resources for you to use in your classroom. So in just a moment, I want you to go ahead and open up that website, and you're going to answer the very first question about your teaching modality that you're using this academic year or semester, and then some of your concerns about trying to teach science inquiry online. So we're going to give you about 1 minute to do that after I say go. Are you ready? On your mark, get set, go. So we've done this workshop now for several hundred teachers across the United States over the last several months. And we've asked these questions to all of those teachers. And so here are some of the results that we've found from a large selection. About 8% of you are going face-to-face this semester. Another 34% are doing a hybrid, and about 43% of you are doing some sort of remote instruction where you are working with students all at the same time, but via online. And then only about 6% are doing asynchronous instruction. Now, this all makes sense that most teachers are doing some sort of online instruction because those that come to this workshop are coming for a reason. I want to just read for you real quick some of the concerns that teachers all across America have been expressing to us about teaching science online. Here's a couple of things. How to get students to interact with each other, addressing the needs of all learners, keeping students engaged, engagement and accountability, students not completing work, engaging students' digital access and meeting all students' needs, and then again, student engagement. And so as I read all of the responses that we get from students, the one word that keeps coming up over and over and over again is engagement. How do we keep our students engaged and interacting with our class online? And this brings us to the Communities of Inquiry framework. This is a framework that you can use to make your online coursework as well as even your face-to-face in-class coursework more interactive. And the Communities of Inquiry framework works this way. It's broken down into what we call 3 different presences. And those presences are a teaching presence, a social presence, and a cognitive presence. And if we break down even more, we think about what students are actually doing when we're talking about engagement. And so within those presences, we can break down everything into interactions. And the interactions that we really are concerned with within the Communities of Inquiry framework is that student-instructor interaction, that student-student interaction, and that student content interaction. And if we think of all of these presences in terms of interactions, then we can start developing lessons and coursework that really gets students interacting. Again, because that's the foundations of the Communities of Inquiry framework. And so what does that mean? If we look at these overlapping circles here, when we're talking about the teaching presence and the social presence, we end up setting a climate as the instructor. When we're looking at the teaching presence and the cognitive presence, we're selecting content that we want students to engage with. And then when we have that social presence and that cognitive presence, we're really trying to build a system that supports discourse between students and the content. And then all of that together gives us a good instructor-facilitated learning experience where we really have a strong interactive community. Now that teaching presence, that student-instructor interaction, we're not going to talk about that one too much today because we're going to focus on those presences that are often difficult to plan and think about in an online space. And that's the social and cognitive presences. Really, how do we go about getting our students to interact with the content and not just lay there and put their head on the table and listen passively? And then how do we get students to interact with other students, both of which we can monitor very well face-to-face, but becomes more challenging in an online setting. And so we're going to go through some practices and ways that we can go about doing those types of interactions online. So I want to start with a simple student content interaction and just give you an example from some of my own courses. So this is an example from a class that we teach on physics, and it shows students interacting with video. And so these videos, which are published by Macmillan, and that doesn't really matter, but these videos are broken up into chunks. And so they'll watch about 5 minutes or 2 minutes of a video, and then it'll go to the next chunk, and we can actually monitor how students are watching these. Now, that doesn't mean that they're necessarily interacting with the video. by just watching it passively, but what we do to sort of get that engagement is embedding questions within the video. So students, we monitor their progress throughout, but then also when they get to a certain point, they have to answer a context-rich question based off of what they were just learning. And those embedded questions are multiple choice, and the students can't move forward in the videos until they get it correct. Now, because they're multiple choice, they will eventually get it correct because there's only 4 or 5 answers and they can just try 4 or 5 times. We don't give them they don't lose any points if they get anything wrong. They get all of the credit if they eventually get it right. And with it being multiple choice, they can eventually get it right. Plus, each question, each answer that they provide that's incorrect, they're going to get feedback, and they'll have to read through the feedback in order to guide them towards the correct answer. So in this way, what we're doing is we're getting the student to actually interact with the content. So they're not just passively watching, they actually have to answer a question based off of what it is that they are doing. Now, this also provides very useful feedback to us as the instructor, because we now know what students are struggling with and what students are doing quite well on. So that was an example of a set of videos that were produced by a publisher. But this is showing an example of a video that I made myself using an online application called VidGrid. Again, showing that student content interaction. So you can see that I created this video with just a Google slide and a screen capture with my webcam. Very similar to what I'm doing right now, maybe a little bit less in depth than what you're watching right now. But these things had both my smiling face built into them, and you can also see where I've been able to embed questions. And just like what I was talking about before, students can't move forward until they answer the questions, or at least answer them correctly. Now, this I can use within my own learning management system. I can make it a quiz, and I can make it something that they can go back and do over and over, right? And that may depend on the types of technology that you have available to you. Now, if you're really interested in embedding questions within the videos that you create, then I encourage you to go watch a great webinar done by my friend Keith Hughes, a historian and educator on the popular YouTube channel Hip Hughes History. Now, you can see that webinar at learning.savas.com/GTD20. And of course, that's going across your screen right now. And he'll go through more of the technologies that you have available to you and how you can make your videos more interactive and engaging. Now, to model this engagement and this interactivity, I'm going to ask you a very controversial question. And you're going to answer that question at the website that you should already have a browser tab or window open to. And that's creatingscientists.com/scienceonline. So you're going to go to that website here in a moment, and you're going to answer the next set of questions that we have built in there for this workshop. And that question is quite simple. What is a sandwich? And more importantly, is a hot dog a sandwich? So I want you to think about that now for a moment, of whether you think a hot dog is a sandwich, and you're going to say yes, no, or you don't know. And then I want you to put your name or make up a name. It doesn't really matter within the discussion. And in that discussion, you're going to say if a hot dog is a sandwich, and if so, why? And if not, why not? What are your reasonings for the answer that you chose? So in just a moment, you're going to go to that website and you're going to answer those 2 questions, and we're going to give you 1 minute to do so, and then come back to this tab and watch the rest of the workshop. Are you ready? Set, go. So this always is an interesting question. I actually often use this question as an icebreaker for my own courses in the discussion boards that we would have at the beginning of a course. And the reason is because it's actually quite controversial. A lot of people think that, yes, indeed, a hot dog is a sandwich. Now you can see the results here. This is from hundreds of teachers doing this workshop over the last couple of months. About it looks like about 60% of teachers are saying that hot dogs are indeed sandwiches, with about 33% saying hot dogs are not sandwiches. And I find it fascinating because if I ask college professors exactly the same question, I usually get a reverse in those numbers, where about 30% are saying that a hot dog is definitely a sandwich and 60% are saying that it's not. I always found that fascinating, but it's not the main point of what we're doing here. The main point has to do with the fact that we're trying to engage you in the discussion that we're having, right? And we just use this hot dog sandwich thing as the context. In an actual science course, of course, the content would be what you would want to be focusing on in these types of questions. But you are paying attention. Now we're going to come back to this discussion in a minute as well, because I want to look at some of the things, some of the reasonings for why you think that a hot dog is or is not a sandwich, and give you an opportunity to discuss with each other. So what's the point of all this interactivity with the students engaged in the content? And I think we all know the answer to that already. These two photos here are great illustrations of one of the problems with online instruction, or at least one of the problems that we could have with online instruction. And I know this one personally pretty well because last semester at the beginning of this pandemic, I remember coming down the stairs and going to the office and opening the doors and seeing my daughter laying on the floor, balled up in a blanket, asleep, with the sound of her teacher's voice coming through the computer. Because what had happened is my daughter got bored, laid down, and fell asleep in the middle of class, which was quite easy to do in the online space. Because, you know, if we're just talking to students, just like if we were to just be talking to students through a lecture in the classroom, it can be very hard to stay engaged. But it's actually more difficult to stay engaged when you are talking, or you have video, or you have something in the online space. And the reason is because there is no face-to-face interaction. There is no sort of being able to see that student and that student being able to see you and knowing that they're able to see you. There's also all of the other distractions that happen when we're sitting in our homes on our computers. There's email, there's the temptation to look at Facebook or Instagram. There's all of these temptations going on. And this just isn't with your students in K-12, it's with college students, it's with grown adults. We know from some of us, from all of the Zoom meetings that we might have been doing, that they are much more difficult to pay attention in because of all of those distractions. Now we can look at the data and see the average audience attention versus presentation time. And you can see that starting off, everybody's very interested. They came to the presentation for a reason. You came to this workshop for a reason because you're interested in the content that's going to be discussed, right? So your interest is high. But within the first 10 minutes, that interest drops rapidly until it starts to peak again at the very end. And the reason is because things get boring. And it's not so much that you're bored by the content, it's that you are distracted. As a human, you are distracted by other things. Your mind, if it's not engaged and interacting, begins to start wandering and thinking about other stuff. And this is just a fundamental truth that happens to be something that goes on in our brains. It's not the student's fault. It's not your fault listening to this workshop today, right? We just have to be cognizant of this fact that we lose interest. We begin to lose focus within about 10 minutes for any presentation. And that drop is rapid. And that's why active engagement is critical. And so you need to have students being actively engaged in your online course too. And so, of course, that's why we're having this discussion about embedding questions within your videos or within whatever content it might be. You need to keep the student engaged in the content for that good student content interaction. And so every 5 minutes, 10 minutes, there needs to be a reset. Now you can notice that I've been modeling that here for you today in this workshop. Every few minutes, right, we stop and we pause, and you have to engage in the content by answering questions on that website that we've been working with throughout the workshop. In that way we can keep the intention high, we can keep the focus, the students' focus on the content that we want them to be focusing on. So we've been talking about the student content interactions. So now let's focus a little bit more on the student-student interactions, where we're trying to get the students to engage with each other. So this photo is showing a synchronous group problem-solving process happening in real time. This is an example from a class that was being run remotely, meaning that students were synchronously together at the same time, meeting at the same time, at the same day via Zoom. And so we used the Zoom breakout rooms here, and the students had access to the Zoom whiteboards that allowed them to go through and do cooperative group problem solving. So we would give students a problem that we would solve. We would do this by putting that problem on a mini site like you're seeing today in this workshop, and then they would go and work together on these whiteboards. And so that's an excellent way for them to be involved with each other in the problem solving process, just like as if they were face to face in class. And as the instructor, I can go back and forth from breakout room to breakout room and see what it is that they're doing within their whiteboard space, and have conversations and make sure that everybody is involved and engaged. Now, another type of student-student interaction that you would obviously do within the face-to-face course is labs, where students come together and work together in groups to answer a research question. And we were able to do that by very similar to how we did cooperative group problem solving using Zoom as an example, especially within synchronous group labs. So once again, students would meet at the same time on the same day, and they would come together in Zoom, and I'd place them in breakout rooms, and they would work together on a lab. Again, going to a little micro website that had the information about the lab in it, that the question that we wanted them to do, to answer, and the types of things that we wanted them to explore. In a lot of cases, what we actually used were the PhET interactive simulations. So students were able to do the actual lab with an interactive simulation online. Other times we had to modify some of our existing labs so that they would work with the types of materials that students would have around their home. In chemistry, examples would be pouring salt into ice water and feeling what would happen with the temperature. In physics, we could have them roll balls down inclines, roll small balls down books, roll cans down books, all of these different things. And it takes some creativity and thinking about what it is a student can and can't do at home, and how you might be able to incorporate a simulation into that. So far, we've been talking primarily about synchronous instruction in science online, but I want you to start thinking about how you can take your lessons and your course materials and try to make them asynchronous. So that way, your students have flexibility in when they can complete the assignments that you are giving to them. Right? There's an accessibility reason for this. If you imagine it, your students are going through some of the same issues that you are in this pandemic. Their parents, their guardians are going to be having the same struggles with work that you might be having in your own home. Right? And so having that ability to work with students later in the day on assignments, in the evenings, or whenever that might be, whenever might be best for the student, is always welcoming for accessibility purposes. Plus, when you have multiple students that are all online at the same time in the same household, that can create issues with internet service, as well as accessibility of laptops or computers within the household. So making your assignments as asynchronous as possible can actually be a good thing for your students. So we're going to talk now about some of the ways that we can make inquiry in science asynchronous. So we've talked a little bit about the possibility of making asynchronous video engaging and interactive for that student content interaction. But really, how do we go about making the student-student interaction asynchronous? And one of the best examples of that would be the lab. The lab in science is absolutely one of the most foundational pieces of what we are doing when we are doing science inquiry. So here's a structure that you can think about for taking your group labs into an asynchronous format. In this way, what we do is we maybe assign a group of 3 students where each student has a role to play within the lab. So student 1 would plan the investigation, and you can have the students plan the investigation in something like a Google Doc that's shared with the other 2 students. And so they're responsible for making that first plan, while student 2 and student 3 are sort of going through and giving comments and helping develop that plan. Then student 2 will take that plan and use it to conduct the experiment, whether it be through a PhET like we just talked about, or through an actual investigation that they do hands-on with materials from around the house. So student 2 conducts the investigation and takes the data. Again, possibly using a Google Sheet or whatever data gathering material or software you might use in your classroom. And then students 1 and students 3 would be able to look that over as is happening, or later in the day or whenever, right? And then finally student 3 would analyze and interpret that data and put everything together into some report template that you might have to report out results of the lab. And again, student 1 and student 2 would be going through and making their comments along the whole process. And so in this way, the students are actually working as a team and as a group, but they have flexibility around when they can actually complete the assignment. At least some flexibility, right? Because obviously student 1's work comes before student 2's and student 3's, so they're going to need to be working maybe earlier in the week. And then these groups would rotate, right? So the roles could rotate from lab to lab, and students have an opportunity to complete each one of these different roles. A question that we get quite often is actually, what resources are out there for labs that can be done at home? And I wanted to really quickly just point you towards a resource that's offered by our partner at Savas Learning, Flynn Scientific. If you go to flynnsci.com/at-home-science, that's the web address sitting there at the top of your screen, they have a large number of resources for high school and middle school online labs. They have videos of the labs as well as activities that students can do for both chemistry, biology, earth and environmental science, and physics. So another important student-student interaction is the student discussion. And so now let's model a little bit about how we might have sort of that asynchronous student discussion. That's very similar to how a student would be talking to another student just face-to-face. However, now it's separated in space and time. Earlier, we had you answer a couple of questions. One was, is a hot dog a sandwich? And then the other was an open-ended question, an open-ended prompt asking you why you thought it either was or was not a sandwich. And here on the screen, you can see some of the responses that we've gathered from hundreds of students that have been through this workshop, hundreds of teachers that have been through this workshop through the last couple of months, and all of their different ideas. And here in just a moment, I'm going to want you to go to creatingscientists.com/science online. That's that web browser that should still be open in your browser. And you're going to go down and click on the link to the spreadsheet. Click here. And I'm going to describe for you what it is you're going to do, and then we're going to pause, and you're going to complete that activity, again, with 1 minute allowed. So when you click on that link to the spreadsheet, this is what you're going to see. You can see where people have put their names and then their their response to is a hot dog a sandwich, and their explanations for why. And so what you're going to do is you're going to look at the third column. The third column is to convince them you're right and they're wrong. So what we ask students to do in these types of discussions is to find somebody within the discussion that they disagree with and try to convince them that you're right and that they're wrong. So in just a second, we're going to pause. You're going to go to that link and you're going to find somebody very quickly within this list and enter into that cell your reasoning for why you think they're wrong. Are you ready? And go. So for this workshop, we decided to use Google Sheets to model our student-student interactions and asynchronous student discussions. And we chose Google Sheets because they're free and they're accessible to everyone. And don't feel like you have to be stuck with Google Sheets, of course, because a lot of learning management systems have very robust discussion board systems. And those are actually excellent resources to use for getting your students to interact with each other in an asynchronous way. So here's an example of us using a discussion board within Canvas, which is a learning management system that I use for my classes. And in this discussion, students are talking about the little L-shaped tube and the pressure. This is a physics question here in buoyancy and pressure in liquids and fluids. And so the first thing that students do when they come across these questions and within the discussion board is they have to give a reason for their answer. They have to answer and they have to give a reason for their answer before they are able to see any of their fellow student responses. And then once they've given that answer, they're able to see all of their fellow students and they can go through and they can find somebody that they disagree with within that framework of discussion that we've talked about and convince them that they're right or they're wrong, or sometimes they're convinced by their colleagues' reasoning. And that's one way that we get this discussion going on. And you can see here we have a group of students that are discussing this, 2 students. We've blocked off their faces and names. And one is saying that point C is enclosed by more oil, and they give a little bit of a reasoning behind that. And another student comes behind and says, but they're at the same depth, right? And expounds upon this idea of depth and pressure. And the student comes back and says, that's convincing. So you can see that they're using that language that we've really set out for them to use in terms of convincing people through argumentation based on evidence that what they're saying is right and what the other person that they disagree with is saying is incorrect. Now, one of the most common questions we get is how do you actually get students to engage in these discussions? And so this comes down to a fundamental law of the classroom that students will only do what you signal to them that you value. And you signal what you value to the students through how you assess them, right? So we actually assess students in their discussions using a rubric. And this is an example of the rubric that we've used. It's very short, really. And all it's really getting at is, did the student do a good faith attempt at the question beforehand, and did they engage in the discussion with other students afterwards? Because that's all we're really looking for them to do, not whether or not the question has been answered correctly or the reasoning is sound. We're just trying to enforce this idea of discussion and getting them to engage through a rubric, and it's actually quite effective. And so this brings us to the end of our workshop, but let's reflect back on what we've discussed. So the Communities of Inquiry framework, again, is broken up into these three presences: the teaching presence, the social presence, and the cognitive presence. Those presences can be thought of in terms of interactions, with learner-instructor interactions, how the student interacts with you, with how the student interacts with other students, and then how the student interacts with the content. And so you're constantly asking yourselves these three questions as you're going through putting together your online materials and your online lessons. How does the student interact with you in this lesson? How does the student interact with the content in this lesson, and how can you keep it engaging? And then how does the student interact with other students in the classroom? And that makes up the foundation of this relatively simple framework for thinking about our courses. Think about the materials that you're developing in terms of interactions between the people and stakeholders involved. And if you do that, then your online lessons are going to really come out to be quite good. So I wanted to thank you for joining me today, and I wanted to thank you for being teachers, because what you're doing is awesome. And I really hope that what we did today can help make you be just maybe a little bit more awesome. So once again, thank you.